Okay, the first question we are going to look at is question 1b part 2. In 1b part 2, you are asked to simplify 18p square minus 8 over 6p square minus 14p minus 12. So we need to factorize both numerator and denominator. In our numerator, part 1, you have already factorized it, and the answer is, hang on, 2, 3p plus 2 times 3p minus 2. Then in your denominator, we can also factorize it, and we will arrive at 2 times 3p plus 2 and p minus 3. This is what you should get after you factorize completely. Unfortunately, some of you didn't factorize it completely. You left the 2 over here inside here. So what you ended up with was, in the denominator, you had 3p plus 2 and 2p minus 6. Then your numerator, it was 3 times 3p, 2 times 3p plus 2, and 3p minus 2. Then you just cancel it out this way. Okay, so this is not completely factorized yet. So over here, when it is done completely, you can cancel all these out, and our answer should be 3p minus 2 over p minus 3. Okay, just be careful with how completely you factorize both numerator and denominator. Okay, sorry, backtrack. I just realized that question 1a part 2. 1a part 2. We have s equals to ut plus half at squared. And then you need to make a the subject. So this was what I saw. This is equals to ut plus 0.5 at squared. Okay? Half was just replaced with 0.5. Nothing wrong so far. But when you try to make a the subject, you end up with 0.5 at squared equals to s minus ut. Then you start to divide both sides by 0.5 t squared. So you get a equals to s minus ut over 0.5 t squared. Unfortunately, we do not like decimal place, decimals inside a fraction. So what should have been done was, from this step, we can choose to multiply everything by 2. So instead of dividing by half, we multiply by 2. They are exactly the same thing. It's just that in this way, you end up with a decimal. Whereas over here, we will have 2s equals to 2ut plus at squared. Then at squared is just 2s minus 2ut. And then a will be 2s over t squared minus 2ut over t squared. Then we simplify this, and we get this. Okay? You can leave your answer like this, it is fine. Then the next one I'll talk about is question 2a part 2. Anybody realize there is an error in the answer booklet? So for those who did this question on their own, you got it correct, you wouldn't have noticed the error. But for those who did it yourself, you got it wrong, then you refer to the answer booklet. Did you understand what it was trying to tell you? If you had tried to understand, then you realize that it doesn't quite make sense. So when you do your correction now, when you refer to this, I need you to think also. Because you can't have the teachers going through every single question with you. Then you must realize, you must understand what they are trying to tell you, so that you know whether it's right or wrong. Okay? If you read and you don't understand, ask. So, question 2A, part 2. The original value of the car is, $78500. Then each year the value of the car decreases by 10% of its value at the start of the year. At the end of 3 years, you decide to sell. Find the overall percentage reduction in the value of the car compared with the original value. So definitely, I want to know how much the car is worth at the end of 3 years. So how do I do that? You can find out value after 1 year is equals to 9 over 10, which is, in other words, 90%. Okay, 90% of 78500. Okay, let me read what I wrote here again. Please look up, because this deals with how you are using the percentage symbol. Value after 1 year is equal to 90% of 78,500. So this is equals to 9 over 10, or 90 over 100, which is 9 over 10, or you can call it 0.9 times 78,500. Then you get a value. Then you find out value after 2 years is equals to, again, 90% times this value, right? Times 90% times 78,500. Okay, so far? 90% of the value in the previous year. This is the value in the previous year. So value after 3 years equals to 90% times 90% times 90% times 78,500. Understand what is happening so far? Okay, then this is simply 9 over 10 times 9 over 10 times 9 over 10 times 78,500, which is the same as, I'm just writing it in different ways for you, depending which one you prefer, okay? It's the same as 0.9 times 0.9 times 0.9 times 78,500. Okay, let us try to simplify this. 0.9 times 0.9 times 0.9, what is that? 0.9 cubed times 78,500. Can you look at your answer key? What does it say? 0.93. So what's the error? They should have written 0.9 cubed. So don't just copy blindly and just write down 0.93 as your corrections, because that's defeating the purpose of corrections by yourself. Okay? So calculate yourself. Find out this value. Okay? The final answer inside is correct, it's just that the working doesn't make sense. So what did you all get? 57226.50. This is the value at the end of 3 years. So could we have skipped all of this because it looks very messy? Yes, we could have. If you understand the question, it is like your it's similar to compounding. Okay, you calculate the value in compound interest. You calculate the interest that you get based on what you are getting from the start of the year. So every year, year after year, you are getting more and more interest. So similar to this, we are calculating the value year after year based on what its value was previously. So we could have done just this. We could have just written this. Value after 3 years is 0.9 power of 3 times 78,500. And you get it straight away. With the dollar sign. So this could have been shortened. But if you do not know why is it like that, then this is the reason with here. All these percentages, whether you want to write it as percent, fraction, or decimal. Okay? Then, how do we present percentage reduction? Do you know the formula for percentage reduction? Do you know? Or do you know the formula for percentage change? You don't go and think about original, which one minus which one. You just remember one, okay? Percentage change. Just remember this one. Percentage change is equals to final minus original over original times 100%. This is percentage change. If your answer is positive, then it is a increase. If your answer is negative, then it is a decrease. Okay? You only need to know this and what the final results mean. Answer positive implies percentage increase. Answer negative implies percentage decrease. So let us use this, and we find that the percentage change final will be 57226.50. This is the final value minus the original, which is 78500, divide by original 78500 times 100%. So this will be, let me just highlight this percent symbol. I highlight it because we are looking for percentage change. If you do have the percent over here, then it is wrong. So my answer will be negative 27.1% after you round it off to 3SF. Okay, this is in 3SF. So since the percentage change is negative, I know there was a reduction. And then I conclude with percentage reduction equals to 27.1%. Okay? Do you get it correct? Next question that I want to talk about is question 4C. Find the values of n for each Tn over Tn equals to 1 over 5. You might not have seen this type of question before, but just remember your basics, your fundamentals. What do we find? What do we get for Pn? Pn earlier was Pn equals to 4n minus 9. Tn equals to n squared plus 2n. So just substitute Pn 4n minus 9 over Tn n squared plus 2n is equals to 1 over 5. This question is just a quadratic question. So do your balancing of equation or your head short or cross multiply, which isn't exactly the correct term. We will get 5 times 4n minus 9 equals to n squared plus 2n. Go and solve your quadratic. You will form a n squared plus bn plus c equals to 0. Then solve to get two values of n. You get n equals to something, n equals to something. But before this, whenever you solve quadratic equations, you must show me what is the intermediate step. So you have three options. Either you factorize, or you use your quadratic formula, or you use your completing a square. Okay? You must have either one of these in red. Must have whenever you're solving quadratic equation. If you go straight from your quadratic equation, then you give me the answer, based on what you key into your calculator because you discovered this shortcut or somebody go and teach you, you will not get a full marks. You're not going to get meta marks, you're not going to get answer marks because you never show me how you got it. You must show me either your factorization or quadratic formula or completing the square. You mean, oh, you mean like this, is it? X plus 3 then x minus 2 equals to 0, is it? Yes, you can, but I know how you did this. Yeah, and then you work backwards, right? It's okay if you know what you're doing. But there are some questions that will cause you to get it wrong. Okay? So you need to know what you're doing lah. Okay, next is question 5. Graph question again, because after what I went through in class, I still saw the same mistakes made. I just want to talk about part C. Okay, so assuming we have the graph already, which looks like this, then you have your equation of graph. This one is ht. Equation of graph is h equals to at plus 16t minus 5t squared. Then in part C, use your graph to estimate the maximum height. How do we present our answer? C part 1, maximum height is over here, right? So I want to see a dotted line to the h-axis. I want to see the value over here. How much is the value? 93. I want to see the number 93. I want to see a label. So this is C part 1, 93. And then at the back of your graph paper, you write down C part 1 is 93 also. So that when I see the graph, I know what you are looking at to get the answers. So then, for part 2, find the length of time that the stone was more than 85 meters above sea level. So you need to draw a line of height equals to 85. You can draw a solid line, you can draw a dotted line. Okay? But once you draw this line, what are you interested in? You are interested in these two values. So I want to see dotted line coming down. I want to see the value over here, which will be approximately 0.35. 0.35. And I want to see this value over here, which is approximately 2.85. Okay, and this is for part C, part 2. So C part 2. Label them. Then at the back, you go and calculate 2.85 minus 0.35, you get the answer. Then part 3. Time taken for the stone to hit the water is found over here. Time taken for it to hit the water. So tell me what this value is from your graph. Write down, it should be approximately 5.9. And then label it as C part 3. Okay, all these numbers, leave it on your graph. Since you're going to be reading it anyway, might as well just write it down so that when you check after you're done in the paper, it is easier for you also. What is shown in your answer key is incomplete. Then part D, by drawing a tangent, find the gradient at 4, 6.4. So somewhere here, draw a line, a straight line that touches the curve only at one point. Okay, so this is your point with coordinates 4, 64. Now when you draw a tangent, we are going to find the gradient. So tell me which are the sets of coordinates you use. Maybe one set over here, maybe another set over here. Then use the coordinates, calculate your gradient at the back of your graph paper. Okay? In physics, you know you have to take many measurements, right? Why? Do you remember why? To make it more accurate. Then let's say you want to measure the thickness of one piece of paper. Vernier calipers, your micrometer, screw gauge, any other way that you can use, any other, sorry? Yeah, measure in a stack, right? So maybe you measure like 50 pieces of paper, and then you measure it, and then you divide by 50. What are you trying to do over there? You're trying to minimize the errors, not find the average. You're trying to minimize, reduce the error. Because let's say the error is maybe 1 mm. Then 1 mm error, you divide by 50 pieces, then the error will be very small, right? In the same way, when you find gradient of a straight line, choose points that are far apart. Don't go and choose points that are so close to each other, then any errors is going to get significant. The further they are, assuming your tangent is drawn correctly, the further they are, the more spread out your errors will be. The smaller your errors will be. Okay? With the assumption that your line is drawn properly. Can? Then, also for this type of question, when they ask you for gradient, then you have to draw a tangent, you find a gradient, right? I have a question. Is your graph very accurate? Is it very accurate? No, right? Because you only have a few points, and then you draw a curve as smooth as you can. And then you draw a tangent. Is the tangent accurate? It is also not accurate. So what do you think of your gradient? Is it going to be accurate? Unlikely it's going to be accurate. But sometimes, by coincidence, you get values that when you calculate, you get a very nice number. Or maybe you get a very nice fraction. Maybe you get a gradient equals to -3/4. Is this value exact? Is it going to be accurate, this -3/4? It's not going to be exact. That is why we are going to leave it in terms of decimal. We're going to change it to 3SF where needed. So maybe this is not a very good example. Instead of 3/4, maybe let's have 7/81. I'm sure you're going to get many decimal places. So instead of leaving it as -7/81, we're going to leave it as -0.08641, so on and so forth. Then we're going to round it off to 3SF, -0.0864. Reason is because it is not accurate. When you draw a tangent to a curve, the gradient is not going to be accurate, leave it in 3SF. Even though Mr. Wong keeps telling you when your answer is exact in a fraction, leave it as a fraction. In this case, no, we don't do that. Because we know it is not accurate. Understand? Understand? I feel like I'm very naggy. Like the same point I keep saying and saying. But I hope you understand. Next one, question 6a, part 2. Find the equation of the line LM. Hey, Zikian, you see in front, it's for me to monitor you, no? So if you cover your face, then something is, you're trying to hide something from me. Okay? So, don't cover your face. Okay, find equation of line LM. Obviously, LM is a line. Right, Kartik? Did you sketch out what LM looks like? Because it will be useful. L is the point 3, 2. So maybe L is over here. And M is a result of a translation of point L by -6, 4. Meaning, from L, I am going to move to the left by 6 units. So, 1, 2, 3, 4, 5, 6. Moving to the left by 6 units. Then I'm going to move upwards by 4 units. So, 1, 2, 3, 4. Over here. This is my point M. Okay? So, I can find out what the coordinates of M are just by counting. 3 units to the left, then another 3. So, my x coordinate will be -6. Then my y coordinates from 2, I move up 4 units, it will be 4. Okay? So the line is like this. Gradient of the line of LM is over here 3, 2, and over here we have -6, 4. We can do it this way. Your gradient formula, 2 minus 4 over 3 minus -6. Sorry, this should be -3. minus negative 3. Okay, so we will get negative 2 over 6, which is negative 1 over 3. 2 over 6. 2. No, this should be 6. I made a mistake. This should be 6. This over here should be 6. 2 minus 6. Negative 4. Negative 2 over 3. Okay, so this is our gradient. This is one way you can do it. The other way is to simply, I don't know whether you can remember, what is the vector that it is translated by? The vector is negative 6, 4. Okay, moving 6 units to the left, 4 units up. Then if I want to find the gradient of this line, all I need to do, the shortcut method, is just take gradient is equals to, you flip them. Whatever is on top goes to the bottom, whatever is at the bottom goes to the top. You get 4 over negative 6, and that is negative 2 over 3. This is the shortcut method. It is based on this. Okay? Then once you have the gradient, you just substitute in a point, and then you can find the equation of the straight line. Any questions? Then I will go on to question 10A, part 1. Yes? You want to go through 6 part B, part 2. 6B, part 2. Okay, I will go to that question after I talk about question 10A, part 1. Okay, 10A, part 1. 5 counters numbered 1, 2, 3, 4, 5. So basically just 5 items are there, numbered 1, 2, 3, 4, 5. You take 2 out at random, one after another without replacement. They even bold it for you. So can you take the same number out twice? Cannot lah. So how can you have a possibility? How can you have a diagram? I'm not going to draw everything, How can you have a diagram with 1, 1 here, 2, 2? Not possible for these outcomes to happen. So there should be crosses over here, or leave them blank. Whereas for the other boxes, you're going to have things like 1, 2, 1, 3, so on and so forth. Okay? The diagonal row must be empty, because it's not possible. Okay, so going back to 6B, part 2. QP intersects OA at a point X. Find QX. What information do we have about all the Q and P? AQ to QF is 2:1. And then AP to PB is 2:1 also. Now because this is a regular hexagon and I have the sides FA, FB, they have the same length. So they also told us the ratio of F to Q, Q to A, which is 1:2, and then for the other side, A to P, P to B, also 2:1. So I can conclude that these two, they have the same length. These two have the same length, and this over here, they have the same length. In fact, these two triangles, this one over here, and this triangle, they are congruent. Okay? So I haven't thought about how to do this yet. I'm just buying some time. Okay, find Qx. Q to X. Qx is equals to Qa plus Ax. So from Q to X is the same as Q to A, then A to X. Then QA, we find it earlier on. In B part 1, part C, we had AQ. So QA is just negative of AQ. So this will be negative 2 over 3B plus AX. AX, do we have that? AX is 2 over 3 times of negative half A. Why 2 over 3? Oops. Sorry, yeah. Triangle AQP. Oh, over here. Comparing these two triangles, AQP and AFB. They are similar triangles. AQP and AFB. They are similar because the sides over here and over here, they have the same ratio. Okay, shortest over longest. Shortest over longest, they have the same ratio and they have a common angle. So these two triangles are similar, and we know that this one over here is point X. We know that this over here is 2, this over here is 3. Okay? Then the distance from A to X is going to be 2/3 of the distance from A to this point over here, which is from F to B. That is why we have a 2/3 over here. Okay? Then from X, from A to this point over here, A to this point, is given to be negative half of A. Because it is halfway down this is the halfway point of your vector A. So this is negative half A. Okay? So once you have all this, you can now expand and simplify. Then you will get 2 over 3 B minus 1 over 3 A. Okay? Brian, understand? Okay. So that's all for 2013 paper 2. Don't understand? Which part you don't understand? Yellow color? Red color? Oh, okay, that's not a good idea. This part, the 2 over 3. How about this one? Negative half A. You understand? No, don't understand. Okay. QY? That's QX. Sorry, my writing not very good. This is QX. Okay, this. 2. Yeah. Sorry, I'm not playing. I'm just trying to make it clearer for you all. Okay. Let us start with this equation over here. Qx is equals to Qa plus Ax. Any problem with that, Vincent? Okay. Then Qa, you can understand that it is negative of AQ. Okay. Then we now need to understand how we can find Ax. We are going to find Ax over here using similar triangles. The two similar triangles are AQP. So over here, AQP and AFB. AFB. How do I know that they are similar triangles? I realize that they have a common angle A. And I realize that the ratio of their corresponding sides are the same. So over here, AP over AB AP over AB is 2 over 3. And then AQ over AF, AQ over AF is also 2 over 3. So I have proven that they are similar triangles. So since they are similar triangles, the distance between A to X over the distance A to this point over here, which we didn't name it, which I'm just going to use this big red dot, is also 2 over 3. Okay? And the distance from A to the big dot is half of the magnitude of A. QP divided by 2. Yes, you can find QP also, provided you have. Do you have FB? Then yes, you can also find QP. You divide by 2, and then you go from Q to the halfway point. Then no, A to Q, then Q to the halfway point. Then you also get QX. How do we know that one is half? You have a hexagon. This is the center. Then this over here, these are all they are all similar shapes. This one over here is actually a rhombus. Right? This and this and this and this. It is a rhombus. So when you cut it in half, this is going to be this and this. They are going to have the same length. So I know it's half. Okay? For no need. Vector question. Okay? Okay, any other questions for your 2013 for those who have attempted? No other questions? Okay, then your homework that was due today is your 2017 E-Maths paper 1, the one given dated 29 June. Okay, maybe